Okay, so for this part of the exercise, we're going to find the max, the minimum, and the average from a set of numbers. So I'm going to reuse the program we used in our previous video, where we were able to insert data into an array and retrieve the data from the array using two separate functions, where we separated the jobs as a data in function and a data out function. Can we do the same for max, min, and average? The answer is yes. So let's do a prototype for average. Let's start with that. So what do we want the function average to do? We either want it to display in and itself the average or return the average back to main. In functions like these, typically you want the function to return something. So you could use it in different programs where the value that it returns can be processed further downstream. So if that's the case, then you need a double as a return type. And we're going to call this one AVG for average, the function. And we're going to do the same. Notice how I try to keep my code consistent in terms of the signature, right? So, and what do we have? Int, and then a semicolon. So this function here, right? This function will return the average value within a set of data stored in an array. That's its job. Okay, so that means when we call it in main, you better have a some variable of type double waiting for it. Okay, but you will only call this function after you've populated the array. So don't do it before that. Doesn't make any sense. So for utilization, maybe we would have something like this: double average. So we have a variable average right here. And we want to find the average after we've populated the array. So we could do that right here, right? So find the average from the data set. Which means the data stored in the array. Okay? How are we going to do this? Well, average is going to be equal to AVG, and then guess what? My array and size. So this will be the way you're going to call that function AVG. Now, if I try to compile this, I'll get a warning or an error that says AVG has not been defined, okay? Because we haven't done anything with AVG in terms of its definition. How does it work? All I did is wrote a prototype here and also wrote how I'm going to call it and how I'm going to display it. So I'm going to display here, display the average. And I'm going to do a cout, average equals, and that would be average and L. Now, again, remember that this will still not work until I actually define the function AVG. Okay? But I'm going to save my code. It's always a good thing to do. And now I'm going to define my AVG function. So one good way to do this, just copy the prototype signature here, and we're going to fill it up. So let's just copy that and do it right here. So your last function, you can put it right on top if you want. So I'm going to paste this, and notice here, because it's at the bottom of my screen, so what I'm going to do is actually paste it right here, so we're in the middle of the screen, just for our purposes to be able to see things. So I'm going to open curly brace, close curly brace. Now, remember here, this is informal, so you need to formalize it. ARPTR, you can name your pointer anything you want. So is this integer here. So the reason I keep it consistent is for good documentation, so the code speaks for itself. Now, it's always a good idea to write next to the function definition what it's supposed to be doing. Okay, So now we're going to do the average. We have access to the array. Okay? So what is the algorithm for average? Well, what you're going to do is you're going to accumulate, you're going to sum or add all of the content and divide by size. Okay? So you need some sort of an accumulator. So double accum, and let's call that our accumulator, and set it to 0. So you have an empty bag, and now you're going to use a loop and fill that bag with the data that's in there. So for, and let's do a for loop, int I equals 0, I less than size, I plus plus. Now remember, I need curly braces here because I'm going to need at least 2 statements because I need to move the pointer. But now let's go ahead and add values to the accumulator. So accum is going to be equal to accum. So I'm writing it formally. Plus the dereference to the pointer. So you need an asterisk, AAR, PTR. Now, is there an alternate way to do this? Absolutely. And if you wanted to make it a shorthand, you would do something like this. Accum plus equal star AAR PTR. So try it out, and it will do the same. So this statement right here, accum plus equal, right? AAR PTR is equivalent to the formal definition for accumulating based on dereferencing this pointer at the end here. Okay, great. So we're not done yet. You need to increment the pointer. Otherwise, you're adding the first element over and over until you reach the size of the loop. I mean, the size of the array, right? So what do you need to do? You need to increment the pointer. So notice my code now is very, very consistent. Dereference, increment pointer. Okay, and that's what you want to achieve while you're writing code. Consistency, so predictability. So now the accumulator has all the values that I need added after the end of this loop. So what do we do? Well, we're going to return whatever was in the accumulator divided by size. And there you have it. Okay? So now assuming size is never 0. Okay? Otherwise, you return a -1. You could do an if statement if you wanted to, just in case you want to reuse this function and somebody messed up and put a size of 0. Now, for our example, let's assume size can never be 0, since we set it here. But if it is 0, then we have a problem. So you better have an if statement here that only returns this if size is not 0. Okay? And now what this will do is it will take whatever is accumulated, divide it by size, that's your average. Well, let's test it out. Let's see how this works. So compile and run. And let's see here. Did I misspell my array? Yes, I did. No, I didn't. Average, my array. What is it? Size. It's R size. There you go. So R size. Okay? It's R size is the local variable for size within main. So size is only local to the function AVG. Okay, so that's where the confusion was. It's a good thing sometimes when we make mistakes to see what's going on, right? So don't hit the panic button, look for the error, read the error messages, and see what's going on. So let's go ahead and compile and run. We're good. So we're going to enter 12, 13, 14, 10, and 9. And the average is 11.6. Okay, so the next video, we're going to do max and min.